that should have. Okay, so for the sake of the video, we're just at the beginning of our vocab. We're going to review real quick that this is what a ray looks like. It's a ray and a half line. And then we have our initial side and our terminal side, our vertex, and then alpha, beta, and gamma. And if you need more of an explanation on that, you can email me because I forgot to have the recording on, even though I set it up for that. All right. Let's go ahead and move on to discussing theta. Okay, so when we have our typical X and Y coordinate plane, right? Theta has to have the vertex at the origin. So the vertex is always going to be at 0, 0. And then the initial line or the initial side must be the x-axis. Okay, so from here to wherever the terminal side is theta. Okay, and I will remind you guys that I do need to see videos or else I have to take some points off, but I understand when people have to take a quick break. Okay, so if it is in this position, if we're going from the x-axis in a positive direction, then theta is considered in what position? What position is theta considered in?
Standard?
Mm-hmm. Okay. Okay. Right, so if it looks like that in any manner, then that is standard position. Okay. Even if the terminal side were to be in a different quadrant, you would just come at it from a different direction and it would still be standard. The only difference is that if it's down here, theta would be what? Up here, theta is, what do you think? Positive or negative?
Positive.
Okay, so theta is positive up here, which means what do you think theta would be if it was down here? And we're coming from this direction.
Negative.
Very good. Okay, so you have to remember those options.
So it's just standard if it's the one line is on the x-axis.
Yep, if
Okay.
initial is on the x-axis and your vertex is 0, 0.
Okay.
If your origin is involved and your x-axis, then you're in some form of standard positioning. Okay, so you're welcome. So how familiar are you guys with degrees? Because I don't want to go over anything that you might feel is redundant or you've already learned it. So do we need to go over degrees? I can. I don't mind. I have my notes. Okay. So I'll give you a little bit of a historical note. One clockwise rotation was said to measure 360 degrees because the Babylonian year had 360 days. Okay, so obviously we have a little bit more than that right now. Right? Good here. Okay, so let's move on and talk about our degrees. Okay, so in the past, you probably just talked about degrees in the sense of, oh no, why is my battery running low? I'm plugged in. Am I not? Oh no, I'm not plugged in. Hold on a second, guys. My battery has decided. Oh, there we go. How that didn't die, I don't know. My battery is still janky. Okay, so what can you guys tell me about degrees? Okay.
Hey, can you please repeat that? You kind of cut out.
Oh, okay, sorry. My computer battery was dying, so maybe it messed with my audio. So can anyone tell me anything about degrees? What can you tell me about them? Anything at all that you know about degrees?
They are divided in minutes and then seconds.
You're correct. So we are going to get to those conversions, just so that everyone can all be on the same page. 1 revolution is equal to 360 degrees. Okay. 1 degree is then equal to 1 over 360 revolutions. Okay. A right angle, and we should all remember this from geometry. A right angle would of course be 90 degrees, and then it's 1/4 of a revolution. And then a straight angle is 180 degrees, so 1/2 revolutions. And I'm only giving you guys this because it probably is going to ask you it in your program. So how do you think you would draw 360 degrees? What do you think it would look like?
Circle.
Yeah, basically. So in that case, the initial side and the terminal side will be the same. Kind of looks a little strange. Okay, but that is our circle with our vertex. Okay, and then obviously our 90 degrees of our vertex. Okay, and then our straight line, we already had one earlier, but I'll do it again. Okay. All right. So, are you guys taking hand notes? Some of you are? Okay. So, what we'll do really quickly is we'll do some quick examples. I want you to do it by yourself first, and then I will do them on the board. So, does everybody have all this, or can I get rid of it? Good to go? Okay, cool. So, we'll do some quick other examples, just to make sure you guys have the degrees down. So I want you guys to draw out 45 degrees. And then negative 90 degrees. And then 225 degrees. And lastly, we'll do 405 degrees. Okay. And if we were really in person, you guys would come up and draw them, but instead I'll just accept you dictating what I'm gonna draw. So go ahead and take a few moments, or I guess some of you might only need a few seconds. And while you guys are working, I'll give you a public service announcement. Monday is a holiday. Don't ask me which one because I get them all confused. But we won't have class because school is technically closed. And even though we're online and I guess I could do class with you, I don't want you guys to feel like you can't celebrate your holidays. So we won't meet on Monday. Next week we'll only meet on Wednesday. But do, email me if you need anything. If you need me to explain anything or set up a time to meet with you on Tuesday, I can do that. I think that's it. Yeah, I think so. And then I guess another idea for you guys to be thinking about too is if you would like to have like a homework hour or a homework half hour, maybe we can all figure out a time frame that would work. Because I know a lot of you guys work. I'm assuming you work in the afternoons or evenings, so maybe mornings would work. I don't know. It's just so you guys can have extra time to ask questions if you need to. But I feel like this class is pretty open forum. So if you need a question answered, you can always ask me. Okay, so 45 degrees. Somebody tell me what to draw. I guess I will give you all the XY coordinate, and I do want someone different for each question. Okay. What do you think? 45 degrees. Where am I starting from? And just tell me pretty much whatever you want to do. What I can suggest is that I would have it in standard position if I'm giving you an XY plane.
For the 45, you're just gonna draw a line, basically, right through the middle, from 0, 0, right through the middle of the Y, yeah.
Okay. So our vertex is again at 0, 0. We have our initial side. We have our terminal side that I just drew based on your direction. So then the 45 that we're actually concerned about is right in here. 45, of course, is interesting because we could also have a 45-degree angle here as well, but we're kind of ignoring that for the moment. So there we go. There is your 45 degrees. All right, someone different explain to me how to do negative 90 degrees.
Like instead of going counterclockwise, go clockwise, starting from the x-axis in the origin.
Very good. So we're still gonna have our vertex here, and we're gonna come down this way. So we have our initial side here, our terminal side here, and this whole thing is your negative 90 degrees. Okay. All right. Someone else explain 225 degrees to us. I'll give you a hint. This one's going to be your initial side again. Where do you want me to draw the terminal side at? Somebody new. For 225 degrees.
In the bottom left hand.
Yep. So we have 90, 80, 225 be somewhere in there. And so then this is our terminal side. And we're coming over. And there's your 225 degrees. Okay. And then the fun one. Where are we drawing 405 degrees? Somebody new.
Would it be in the upper right and then it kind of goes like a full circle and then a little just to reach the vertex?
You are correct. So here's your terminal side, but because it's more than 360 degrees, you have to basically draw your circle. So from here all the way around, passing and then back through. Very good. Okay. Any questions with the drawing aspects? Okay. It was mentioned earlier that we can do the conversions. So we're going to look at that relatively quickly. That is our next example. Okay. I will try to get us through all of section 7.1. If we don't make it through the whole thing, I will put up my teacher notes. I am going to go get my copies made. Okay. Are we good for this one? Move on to conversion? Okay, cool. Okay. So when we want to convert between degrees or I guess decimal comes first. Decimal, degrees, and minute, and second. Okay. So it says here that although subdivisions of a degree may be obtained by using decimals, the notion of minutes and seconds may also be used. So 1 minute is denoted as, so 1 minute is one with like, I guess you would call that a little hyphen, not a hyphen. What's the Englishy thing where you go and you do, oh, apostrophe. That's what I wanted. So there you go. It's a little apostrophe. And then it's defined as 1/60th of a degree. Okay. And then 1 second is 1 with 2 apostrophes, and it is equal to 1/160th of a minute, which is also equal to 1/300 and wow. Yep, you got it. Throw that TH on there and you got it. All right. An angle of 30 degrees, 40 minutes, and 10 seconds would be written as the following. So here's your mini example. So 30 degrees, 40 minutes, and 10 seconds would be 30, 40, and 10. Okay. All right. So what's something really important you have to remember about your revolutions? So like up here when we said, or I guess it was the notes before, we said 1 revolution is equal to 360 degrees, and 1 degree is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So that's like the little box of knowledge that they're giving you. But what word has to go in here? It's not just 1 revolution. It's what? What word has to go in front of that revolution? What do you guys think?
Full.
Hmm?
Full.
So not complete, not what kind of revolutions do we have? We have clockwise and yeah, there you go, counterclockwise. Counterclockwise. Okay. All right. So that is that. And George, just so you know, we took notes on some vocab. You can catch up with that on the video, but I started the video late because Zoom told me it was going to start it immediately, and it didn't. So the video is a little bit interesting in the beginning. Okay, so any questions on degrees and converting to minutes and seconds? I think there's a historical part for you in your textbook. Yeah, but it's like super old history. I cannot tell you why we really deal with degrees in minutes and seconds. It would be interesting if someone wanted to look it up. My assumption is it might have something to do with like, you know, the earth is round and people did a lot of exploring. So maybe in a minute you cover so many degrees of it. I don't really know. I'm just assuming. It might be something interesting to look up. So let's look at some examples on converting. Are we good with this? I can erase it? Cool. Okay. All right. All right, so here's our example. So for A, they want us to convert 50 degrees, 6 minutes and 21 seconds to a decimal in degrees, and then round that decimal to 4 places. So we're rounding it, we're sending it to be a decimal in just degrees to 4 places. And apparently we can do this both algebraically and on the graphing calculator. So we will see if I end up getting it correct on the graphing calculator. And then B, we're gonna go from 21.256 degrees to the degree, minute, and second notation. So degree, minute, and second. Okay, so I want all of you to go ahead and work on your own solutions. And then when everyone's ready, we will go over the algebraic and the graphing options. Though, to be honest with you, except for a quiz or an exam, if you can do it on the graphing calculator, that's probably all you will need for the program. Okay. So, what do you guys think? What should I do for the first one? Or do we need a little bit more time?
The answer that I got for the first one was 50.10583 degrees, decimal degrees.
Perfect. Do you want to walk everybody through it? What's the first thing we need to do?
I just put it into my calculator and did all the conversions. So
Okay. So if we so I guess since it might be a little bit hard for you to walk everyone through it going back on your calculator, I'll write it across and then you can let me know if it kind of matches up. Make sense? Okay. So the first thing we need to remember is that 1 minute equals 1/60th of a degree. So let's write that over here. So 1 minute equals 1/60th. And then we know that 1 second equals 1/300,000th of a degree. Okay, so we can use either this option or the other option is to do basically 1 second as 1/60 times 1 over 60. If you're doing it by hand, it really just depends on what you're most comfortable with. And I assume you all have a calculator, so of some kind, so I'm sure you can plug it in. So then we have 50 degrees. That's obviously going to stay the same. Then it'll be times 6 times 1 over 60. And then, actually not times. That's a plus there, sorry. Plus. And then 21 times either, like I said, you can do it either way. Okay. And then that, of course, leads you to your 50 degrees. Then you'll have plus 0.1 degree plus 0.0058 degree. Now remember, we only needed 4 decimal places. If you went further, that's fine, but it's fine for me. Just know that if you did it in your program and you didn't round up correctly, that could be why you missed it. Okay. But yes, you may use your calculator. Obviously, if there's a question like this on the exam or on the quiz, I would want you to actually write it out so I know that you know what you're doing, both on the calculator and algebraically. Okay, did anyone different get the second one?
I got 21, 15, 21.
Close. Remember, you want to round up for your last one. So 21, 15,
22.
and 22. Very good. Okay, and if we do the algebra, we're going to have 21. That's going to stay. Then we'll have plus, and it's the 0.256 of the degree that we have to then change. So then if we break that down again, what we can realize is that if we multiply this by 1 degree there, that they just do that so you know what to break apart. So then we'll convert with the 1 degree to 60 minutes. So it'll be 21 degrees, 60 minutes. Okay. And then we break that up into 21 degrees plus 15 minutes plus 0.36. And then oops. The heck was that? And I apologize if this is really long or redundant for some folks, but I just want to make sure that everybody sees all the steps written out. I wouldn't want anyone to feel lost. Okay, so then we end up with 21 degrees plus your 15 minutes plus 21.6 seconds, but then we're going to just round. And we're going to drop out the plus signs. Okay. Any questions on converting? Okay. Probably will be in your homework, but if you need to, you can refer back to this video, or you can also, do what I do, which is refer to the worldwide YouTube service. There's also, of course, examples built into your Pearson. And I believe there are also a ton of videos that are linked to your Canvas. It's crazy. Okay, so are we good with all of this? I'll give people a few seconds to finish copying. And then mentally, what you guys want to be thinking about is radians, because that is what we are going to go into next. Does everyone have everything? Yeah? Okay. All right. Okay. And if I find that we are going through things a little bit fast, I will try to make class as fun as possible. So I know there are some Kahoots we can do. Of course, I would have to go through the very aggravating task of figuring out how to write math questions up in Kahoot, but I know that's a fairly fun game idea that we can do at some point. Okay, so radians. Tell me about them. What can you tell me about a radian?
Okay, 2 pi's is closely resembled to 360 degrees.
Okay, so when you hear the word radian, you should absolutely, your brain should be screaming that we're going to be doing something with circles. And unfortunately for trig, I feel like circles is what we deal with almost the most. So a central angle is a positive angle whose vertex is at the center of the circle, and the rays of the central angle intersect on an arc of the circle. If the radius of the circle r and the length of the arc subtended by the central angle is also r, then the measure of the angle is 1 radian. Okay, so that just basically looks like this. If we have a circle, and you'll have to apologize that my circles are going to look rather donut shaped on here. And we have our vertex. Then that just means that we have an initial side. Okay. And we have our terminal side. Okay. And then if this arc and these measurements are all r, then this angle inside here is equal to 1 radian. Okay. All right. You can read more about that if you wish. Okay. The theorem we are going to talk about, though, is for arc length. Okay. And unlike geometry, we don't have to write a lot of proofs in trig. We just have to do the problems. So that's nice. Okay, so for a circle, of radius r, oops, a central angle of radians subtends, and for those of you who are like me and don't know English words, subtends means intersects an arc whose length is s. Oh. Okay, so s equals r times theta. Okay, so if you worked out the unit measurements for this, you would find out that the radians divide out, leaving you only with the unit lengths. So we'll do an example in a second when you guys have this written down. So your example is Okay, so if we had to find the arc length, or S, when we have a radius of 2 meters and theta is 0.25 radians, what is our S going to be? How do we figure it out?
We multiply 2 radius times 0.25 radians and we get half 0.5.
Hmm. Okay. So make sure you go ahead and do that. And then when you're ready for that, I am going to give you just kind of like a listing of conversions that they've already done for us, that people basically take for granted. Then we will try to get through example 4 together. And then examples 5 through 8, I will probably have to put up online for you. I'll put everything up online for you. But then what I want you to do is between now and Wednesday, I want you to look at examples 5 through 8. And if we need to go over them verbally, we will. If not, just write them down so you have them. And then we can move on after that. And then what I'm doing is that on Wednesday, if we need to continue with the examples, we will. If not, we can go over any questions you have from 7.1, any homework questions, and then we'll move on to 7.2 if you don't have any homework questions. So if we want to convert from degrees to radians, or from radians to degrees, okay? This is what we know. We know that 1 revolution is equal to 2 pi radians. And we know from before that that's 360 degrees. Okay. The next thing we know is that 180 degrees, or I guess we'll just keep it the same. So half of revolution is equal to pi radians, which is 180 degrees. And then they don't give it to you, but if we follow this same suit, what, 1/4 of a revolution would be pi over 2 radians is 90 degrees. Now, if you guys wanted to go through and figure out, or if you really want, someone can email me and ask. I can find you guys a table that just has degrees and radians, but you guys can also just as easily find it. Someone just email me and let me know if you think it would be helpful to add it to Canvas. If you think it'll be helpful, I'll find one. If you think you can find one on your own, that's fine. We only have about 10 more minutes left, so I will put up example 4. Okay. So A, they want you to convert the following from degrees to radians. So degrees to radians, and they want 60 degrees, 150 degrees, negative 45 degrees, 90 degrees, which we already did if you paid attention, and 107 degrees. Okay, and then the opposite is example 5. And they want you to go do the opposite. They want to go from radians to degrees. And they want pi over 6. Three pi over 2. Negative 3 pi over 4. D is 7 pi over 3 radians. And E is 3 radians. Okay, so we only have 6 minutes. If we don't get through all of them, that's fine. I can put it up online. Do you guys need a few minutes to work on it, or do you want to work on it as we go?
As we go is fine.
What's that?
As we go is fine.
Okay. So I think I forgot 2 of your conversions, and I do apologize because I am writing everything. Obviously, this will make life a lot easier. 1 degree is equal to pi over 180 radians. That will obviously help. So then conversely, 1 radian is equal to 180 over pi degrees. So these two we're going to definitely use a lot. Okay. Make sure you write those ones down. Okay. So if we take 60 and we're going to multiply it by 1 degree, 1 degree is also written as what? Pi over 180, right? Okay, so you're essentially taking 60 pi and dividing it by 180. So what's that become?
1/3 pi.
Pi over 3, yep. Radians. Okay, make sure you label. The program might not have you label because they might have it built in, but make sure you label. So then if you follow that same process here, you're basically going to take 150 pi divided by 180. So what do you get there? Somebody different. What do you guys get?
Can you say that again?
If we take 150 pi, so I mean, essentially, if we take 150 divided by 180, what's your fraction there?
Would it be 5/6?
Yep. So it's going to be 5 pi over 6. Right? Okay. And I don't want you guys to get super bogged down by this. So even though we have a few minutes left, I want us to, I want to be able to answer any of your course questions in the last 4 minutes. So I will make sure that I put the rest of these and the rest of the examples from section 7.1 up later this afternoon after I scan it into the system. Anyone have questions either from today or going forward? Okay, so on Wednesday, we're going to either move on to section 7.2, or if you need me to explain any of the leftover examples from 7.1, we'll do that and then move on to 7.2. And then remember, you want to write down that on Monday, we won't have class because school is technically closed. Okay, just for Monday. I want to make sure that I see everybody's smiling faces on Wednesday. Okay, any other questions that I can answer for you real quickly here at the end? Okay,
I have a question.
sure.
Do you want the fractions or are the decimals okay for the radians?
So if you're giving it to me on a quiz or a test, I will take either. Although I will tell you that typically, like once you get the hang of the conversions, you'll almost have them all memorized unless they're weird ones. So then you'll probably just know the fraction by, off the top of your head. You don't really want to include pi. So if including pi is why you're getting a really weird decimal and not one that you can easily convert into a fraction, then just try working the numbers without pi included. And then pi can just be written down as the symbol.
Okay.
I think for the program, you would have to see what they want. If they want you to include pi, then they might want the decimal answer. The program almost always tells you what it wants. So,
Okay.
any other questions? Okay, so I do apologize if it seems a little Charlie Brown boring, but you just kind of have to get over the beginnings of trig, and then we'll start to really do a lot of intense problems where, you guys will get to write everything down, and then I might have to take a picture of my board to continue on with the next part of the problem. That's typically more calc, but I also write really big, so we might end up having to get some multiple boards in. But all right, well, I'll see you all on Wednesday, and if you have any questions, please email me. If you need extensions or anything for whatever reason, give me an email if I haven't already given it to you. Okay, thank you so much for attending class today. I'll see you all on Wednesday. Bye, guys.